Okay, guys, picking up in lesson 6.5 where we left off. As we pick up here, we're solving radical equations, right? So equations that have one, or as you're going to see here, more radicals in them. Now, as we look at these all have radicals. I might need to go back and talk a little bit. On the front page, they all had radicals, or if they didn't have a radical, they had a fraction exponent, right? A rational exponent. So knowing what to do with those. Now, okay guys, as you look at example A there, square root of x plus 7 minus 5 equals x. Flip back if you need to. What was our process? What do we do when there's one radical? What was our goal? First goal, Kendra? Yeah, our goal is to get the radical by itself. So when I say get the radical by itself, right now the radical is the square root of x plus 7. Is it by itself on its side of the equation? No. What's hanging out with it that needs to move away? That 5, right? And how do we move a 5 that's being subtracted? You're going to add 5. So this is minus 5, so I'm going to add 5. If I add 5 on the left, we add 5 on the right. Okay, so this is a step just like what you would have done on Friday. Square root of x plus 7 stays. Square root of x plus 7. Minus 5 plus 5 will cancel. On the right, what is x plus 5? X plus 5. Because one's an x and the other's a constant, they can't be added. It's just x plus 5. Okay. Is my radical by itself? Yes, right? Radical is by itself. So what was the plan that I talked about in the video on Friday? Once the radical's by itself, what do? Yeah. In order to get a radical to cancel out, we want to square it. Okay? And you have to look at a square root has an invisible index of 2. So we need to raise it to the power of 2. If this is a cube root, we'd raise it to the power of 3. If it was a fourth root, we'd raise it to the power of 4, whatever we need. So we're going to square this. If we square the left, we're squaring the right. Okay. Square root of x plus 7, quantity squared. What happens when you square a square root? Yeah, you get whatever's under the square root. Kind of goes back to square root of smiley face times square root of smiley face is smiley face. Square root of x plus 7 times square root of x plus 7 is x plus 7. Okay. What about x plus 5 squared? What do we get when we square x plus 5? What are you thinking, Eli? You are 2/3 right. He said x squared plus 25. He's missing something in there.
X squared plus 10x plus 25?
Where would you get a 10x in there, Ethan?
Isn't that the thing where it's so you got 25 squared, then you got that 5 times. That's the way I did it on the home. And I know that's.
So what did you do? What's the math that you did here?
I did what is it like the thing that times the thing goes into 25. So 5 is the square. Yeah, that. What factor?
If I write it out as x plus 5 times x plus 5, when you guys see it like that, how do I multiply x plus 5 times x plus 5?
Foil.
We FOIL. And that's the word Ethan couldn't come up with right there, which it's not about knowing the word, it's about knowing what to do. Okay. So right, yeah. So Eli gave me exactly what I wanted to hear. Okay, common wrong answer of x squared plus 25 because that's doing, okay, x squared is x raised to the power of 2 is x squared, 5 squared is 25. What you've got to remember here is you're squaring that quantity. So x plus 5 times x plus 5, which means you need to FOIL. Okay? So that you can see it. I'm not have to write out x plus 5 times x plus 5. But I think a lot of you still need to see that. So Okay, my left is going to stay x plus 7 for the moment. When we FOIL, x times x is x squared. Then we do outsides. X times 5 is another 5x. And 5 times 5? 25. Now, I probably should have gone ahead and done it there, and I didn't. What's the cleanup step? 5x plus 5x is 10x. So I'm writing a lot more steps than I really need to be here. You could definitely condense your steps some. So x plus 7 equals x squared plus 10x plus 25. So I said Eli was 2/3 right because he has the x squared and the 25. If you leave out that 10x, though, that definitely kills the problem. Okay. So now we have to think about how do we go about solving here? You can. I mean, I guess what we need to talk about is what is our goal here? I have x plus 7 on the left. I have x squared plus 10x plus 25. If it's just x's and numbers, we would get x's on the left, numbers on the right, yes? But it's x's, numbers, and an x squared.
Do you want the x squared by itself?
If it was just x squareds and numbers, I would go for the x squared by itself. But I've got x squareds and x squared, x's, and numbers. So what would you say? But Connor?
Quadratic formula.
Quadratic formula is one option. I actually hope we don't have to use quadratic. With that thought in mind, what do we have to make this equation equal to if we're going to think quadratic formula? 0. I hope to go a different direction rather than quadratic formula, but it still stands that because there's x squared, there's x's, there's numbers, make this equation equal to 0. Now, to make it equal to 0, what's going to be the easiest way to make this equal to 0? Subtract the x and 7 over. Remember, I like to keep my x squared positive as often as I can. So I'm going to subtract x, which means I'm also subtracting x from 10x. I'm going to subtract 7, which means I'm subtracting 7 from 25. X minus x, 7 minus 7, all gives me 0. On the right, x squared. What is 10x minus 1x? 9x. Help me out, guys. Come on. You can do this. 25 minus 7? 18. Now, Connor suggested quadratic formula. And we can use quadratic formula here. It would get you the right answers. However, I think you guys will be a little less intimidated if we go a different direction with this than quadratic formula. Because some of you guys are dying with the thought of quadratic formula. What do we usually check before quadratic formula to try and solve this? Does it factor? You guys remember factoring?
It's even worse.
You think it's worse?
Yeah, I hate that.
I don't think you're in the masses here. I think you're in the minority. I would prefer you guys think. What, you guys would prefer quadratic formula?
Yeah, I'd say factoring is 3.
That dude, he's saying
Okay, well, here's what I'm going to tell you as a teacher. You need to, factoring, you can make a lot less mistakes in factoring. Work on practicing your factoring with me today right here. This is a perfect place to practice it. Okay, because, so when I'm talking factoring, 2 parentheses, x squared breaks into what? X times x at the beginning of each parenthesis. And this is the easy type factoring. We do have some difficult factorings. Don't get me wrong. This is easy factoring here. That's why I want you guys to be able to do this factoring at least. Think product and sum, or multiply and add. I need 2 numbers that give me a product of 18. So two numbers that multiply to 18, and those same two numbers have to do what? Add to be 9. I use the word sum, but you can say add to be 9. So what multiplies to be 18 and adds to be 9? A positive? Yeah. So x plus 3, x plus 6. Okay. Think back. How do we actually finish solving here? How do we actually finish solving?
You said each one of them equal to 0 and then
Yeah.
give the x sum up.
Yeah. Zero product property says if two factors multiplied equal 0, we set them each equal to 0. And so we're going to set x plus 3 equals 0, or x plus 6 could equal 0. If it's x plus 3, what do? Subtract 3, and I get a possible answer of -3. If it's x plus 6, what do? Subtract 6, and I get a possible answer of -6. Now, we've got one last situation to think about here. And I wasn't here Friday to stress it. You watched the video. But back, the very first thing in the notes, I started mine. I don't know if I did on the video or not, but an important thing to remember when solving equations where you have to power both sides is to check for extraneous solutions. Where this often happens is when you have to power an x that's not under the radical. Okay, so when we had to power an x, we had to raise this x plus 5 to the power of 2. We very possibly have an extraneous solution, which means before you proceed, check your answers where? The very original problem. So, -3. -3 plus 7 is 4. Square root of 4? 2. 2 minus 5? -3 equals x. What was I just putting in? -3. Does -3 work? It does. Okay, let's check -6. -6 plus 7. 1. Square root of 1? 1. 1 minus 5? -4 equals x. What was I putting in? -6. Does -4 equal -6? No. So -6, even though we did all that work, is not one of my actual answers. Notice I went back to the very original problem. I didn't go back to any place after I squared or anything. I went back to the very original problem before I did anything to it. Questions? There's a reason I saved this part for in person. I didn't think this would go over well via video. Or maybe I was wrong. Maybe it would have been perfectly fine. But okay. Well, start thinking about B then when you're ready. I'm going to write a little note up here to check for extraneous solutions in this section. Okay.
You go back to the last one, I was cleaning him up and it just,
I can?
oh, I'm sorry.
That's right. Okay. B when you're ready. What's step 1 in B?
Right.
Subtract 3 so that we can get the what? Good. Radical by itself is the goal. So we want that square root by itself. Plus 3 is not under it, so we're going to subtract 3. On the left, that leaves me with square root of 5x minus 1. On the right, X minus 3 is X minus 3. Yes? EXTRANEOUS.
I don't know if I mixed it or what, but how do you know if a solution is extraneous?
If a solution is extraneous, it won't work when you put it back into the original problem. You have to check your solutions.
Oh, right.
Okay? It's a thing we all hate doing. And I say we because I am so much a part of this. I hate taking the time to check a solution. Okay? But it's necessary here. Okay, guys. Are we there? We got the radical by itself. Now what? Okay. To get rid of that radical, we're going to square it. If we square the left, we square the right. Bless you. What happens when you square the square root? It goes away. So this becomes just 5x minus 1. What happens when I square x minus 3 squared? What do we have to do here? What do we have to do in the last problem? Foil, right? Okay, so that means if you are the type person that you need the visual, then here's what I'm going to do right now. X minus 3 times x minus 3. Some of you are probably fine without that visual, but for the rest of us, there's your visual. Okay, FOIL. X times x is x squared. Outsides, x times minus 3, minus 3x. Now, how talented are you? Can you hold that minus 3x in your head and then get the next one and go ahead and put them together? I'd like to if you'll let me. Because of what we're doing, they're going to be the same, right? Minus 3 times x is again minus 3x. Minus 3x and minus 3x is minus 6x. Because you're squaring it, it's going to be two of the same. So, saving myself a step there. And minus 3 times minus 3? Plus 9. Okay. What's the next step? Okay, she says subtract the left because my goal is to somehow make my equation equal to 0. So, and I like my x squared is positive. So I'm going to subtract 5x and we're going to add 1. 5x minus 5x minus 1 plus 1, I have 0. On the right, x squared, then what? Minus 11x plus 10. Now, there is a part of me. Okay, so what is the step I'm going to take here? I guess I should ask that first. I'm going to say factor. And there's a part of me that wants to say, okay, if you want to avoid the factoring and just do quadratic formula, go for it. But here's the other part that's fresh in my head. I was brushing up on I-STEP topics, which I guess in this particular class, a lot of you guys are sophomores. However, juniors, you have I-STEP coming up. What is one of the big things on I-STEP? Factoring. Juniors and possibly seniors. Seniors will be a little bit later, I think. But factoring. Okay, you have to be able to factor. That's one of the things we're looking at. And so with that in mind, quadratic formula is necessary also, but you can't just totally avoid the topic of factoring. And I think the more you do factoring, the more you'll grow to like it. I really do. Okay, so 0 equals, I'm going to do 2 parentheses. X squared is x and x. We need two numbers that what? Multiply to be 10. Add to negative 11. So multiplying to be 10. 1 and 10 or 2 and 5? Which one's going to add to be 11 given the right signs? 1 and 10. Okay? So, if they multiply to be positive, they have to be the same sign. If they add to be negative, both negatives. So minus 10 and minus 1. Are minus 10 or negative 10 and negative 1 my answers? No. Set them both factors equal to 0. X minus 10 equals 0 or x minus 1 equals 0. Solve for x. Add 10 in one, add 1 in the other. So we get solutions of 10 and 1. Are we ready to move on? No. You need to check, yes? Okay, especially because there's an x over here that we squared outside the radical. That means likely extraneous solution. So, where do I plug this 10 and 1 into? The very original problem. Okay, don't do it after you square it. So put in 10. 5 times 10 is 50 minus 1, 49, square root of 49, 7 plus 3, 10. And equals x. What was I plugging in? 10. So it appears 10 works. Okay. What about 1? 5 times 1 is 5. Minus 1, 4. Square root of 4, 2. Plus 3, 5. Equals x. What was I plugging in? 1. Did it work? No. Now, keep in mind, don't ever assume because one answer works, the other doesn't, or vice versa. It is possible to have no working answers. It is possible to have more than one working answer. Not as likely, but it is possible. So don't fall into the trap of, oh, guaranteed, this one worked, the other one doesn't. I don't have to worry about checking it. Okay? Same thing. Yep, I just got lazy and did not write the word or. The virtual question, nope, you're good. The virtual question was, on the first one I wrote or, the second one I wrote a comma. I just got lazy and did a comma instead of or, okay? In Math Excel, if there's only one correct answer, you'll only put the one correct answer. If there's two answers, they usually want you to separate them with a comma, don't they? When it comes to paper and pencil, I'm not very, it doesn't really matter to me either way. But no reasoning there. Yes?
So this one be another question. If it goes from -2, is then -2 plus 3, then what do I do that?
Say what now?
Like when we plugged in 1 for 5x minus 1,
Uh-huh.
square root of 4. Could the square root of 4 be -2?
No, because a radical always wants the positive root. Okay, so the question there was, when we said the square root of 4 up here, we said the square root of 4 is 2. And when you look at the radical always wants the positive solution. Now, in pointing that out, why is Megan asking that? Because if the square root of 4 could be -2, -2 plus 3 is 1, and then wouldn't that work? And it would. And that's why one of them doesn't work, is because a radical only wants the positive root. Okay? If they wanted the negative root, they'd put a negative in front of the radical sign. Okay, I'm kind of thinking, it's been since last week since I was in the Math Excel assignment, I'm kind of thinking I want to do C and maybe not D. And hope I don't regret that decision. Oh, actually, they're about the same now that I think about it. Okay. Okay, so let's do at least C or D. We need to do one and look at what happens here. what do you notice? There are how many radicals? There's 2. Okay? We had one. You guys had one. I wasn't physically with you. Part D on the front side, you had 2 radicals, yes? Instead of we got one, normally we get the one radical by itself. When there's 2 radicals, what was our goal? We had to separate them. And we still need to separate them. Now, on the front side, it was real nice because we separated them and there was 1 radical on each side and it made it beautiful. I'll be honest, it's going to be a little challenging here. So, we still need to separate the radicals. Your job is to get 1 radical by itself. And my recommendation, if we get 1 radical by itself, is to start with the bigger one. So let's start by getting radical square root of 2x plus 1 by itself, which means what's my first step? We want to keep this radical here gets by itself. We're going to add the square root of x across the equal sign. So then I have square root of 2x plus 1 equals, and what is 1 plus the square root of x? 1 plus the square root of x. Now, I'm going to actually reverse it, just the way my brain works. I'm going to say square root of x plus 1. If you left it as 1 plus square root of x, it's fine. Okay, we have the radicals separated. This radical is by itself. So what do? We're going to square both sides. On the left, what happens when you square the square root? You get what's under the radical. So on the left, we have 2x plus 1. What about the right? We're going to have to FOIL. Okay? So, and here's what's going to happen, guys. We're still going to have square roots in our problem at this point. Okay? Because we have this other plus 1 here. So, we are going to FOIL. So, hang on with me. I'm going to write it out. I feel like you guys will do better if you can see it. Square root of x plus 1 times square root of x plus 1. So, when we FOIL, 2x plus 1 still on my left. What is the square root of x times the square root of x? X, yes? You could say square root of x squared, but easier to just say x. What is the square root of x times 1? Square root of x, or if you prefer, some of you might prefer to see it as plus 1 square root of x, but it is just square root of x, I agree. Insides, what's 1 square root of x? Another 1 square root of x, or if you prefer, square root of x. I'm okay with that. And then what's last? 1 times 1, which is 1.
So when you add those, wouldn't it finally just become x then? No.
Nope. Okay, let's clean up the right and see what happens. My left is still 2x plus 1. On the right, x is x. What's 1 square root of x plus 1 square root of x? 2 square root of x, which is part of the reason I put the 1's out front. And then we still have a plus 1. Okay, guys, what's the problem? I don't want to set it equal to 0 yet, because I still have what? A radical. Okay, good news is we did have 2 radicals, yes? Now we're down to just 1 radical. When you have 1 radical, what's our plan? We get the radical by itself and then square both sides. We're going to go through the process again, is what I'm saying. Okay, so I'm going to keep this radical by itself. So if I keep 2 radical x here, could we move the x and 1 to the other side? So if it's a positive x, we'll subtract x over. If it's a plus 1, we will subtract 1 over. Okay, do some cleanup. 2x minus x is x. 1 minus 1, 0. So my left side just becomes x. What about the right side? X minus x, 1 minus 1. So I'm left with 2 square root of x. Okay. Is our radical term by itself? And I'm going to go with yes, because there's nothing else being added or subtracted to it. We could move the 2 and divide, but then we have to deal with fractions, and no one wants fractions unnecessarily. It is okay to have a number being multiplied by this when we go to square it. That is fine. We'll talk about what happens, but it is fine. So, radical term is by itself. We're going to square it. If we square one side of the equation, you square the other side. What happens when you square x? X squared. Okay, on the right, be careful. 2 square root of x, and we have to square that. What is, think of just the square root of x. What is square root of x squared? X. Square root of x times square root of x is x. Then we have this whole number 2 out here. What is 2 when you square it? 4. So when you do 2 square root of x and you square it, what am I going to get? 4x. It's not FOIL because there's no plus or minus sign involved. It's just one term. We only FOIL when there's adding or subtracting. There's 2 terms involved. Okay, guys. We have an x squared term. We have an x term. Make the equation equal to 0. I'm going to keep my x squared where it is and subtract 4x over. X squared minus 4x is x squared minus 4x. 4x minus 4x is 0. Okay, guys. We're again thinking factoring. Factoring looks a little different here, though. Dig through your factoring resources. There's not 3 terms here. So I can't do traditional 2 parentheses, product and sum. And since there's x squared and x term,
Is this the plus or minus, like plus 2 and then minus 2?
no, because there's an x term. So Ethan's asking about, is this the like x plus 2 and x minus 2? If it was x squared minus 4 without the x, I'd be all with you. But it's x squared minus 4x. What do both terms have in common? An x. What is that called when they have something? A GCF? Greatest common factor? Factor an x out here is what we're going to do. Yes. You have x times x minus 4. It's not 2 parentheses, but still 2 things multiplying. X times x minus 4. And so when you have 2 factors multiplying, what do we do with each of them? Set them each equal to 0. So we're going to set x equal to 0, and we're going to set x minus 4 equal to 0. So what are my possible solutions? 0 and what? 4. Because x equals 0 is already there. And if it's x minus 4, you're going to add 4. And so we have possible solutions of 0 and 4. Okay, now, while I get my screen back, what do you have to do to finish this problem off? Check for extraneous solutions. Don't stop there until you've checked. Okay. Now, where do we go to check these? Original problem. Don't try and go for after we've moved things around and squared things. Original problem. So, 0. Oh, I like checking 0. That's easy. 2 times 0 plus 1 is going to be 1. Square root of 1? 1. Minus square root of 0 again. Square root of 0 is 0. So 1 minus 0 is 1. 0 works. Shall we check 4? Yes. 2 times 4 is 8 plus 1, 9. Square root of 9, 3. Minus square root of x. What was I putting in? 4. So square root of 4 is 2. We already had a 3. 3 minus 2 is 1. They both work. Is that a possibility? It is. Okay? So, problem took longer than I remembered. Your homework to finish for tomorrow is lesson 6.5 in Math Excel. Okay? Let's see. Quizzes are in Skyward. Trying to think if anyone in this class has to make up my quiz, and I can't remember. Nobody's coming to mind as I look around, so maybe that means you guys all got the quiz. I think it's 6-star. I have several people that have to make it up, so I think you guys are good here. Quizzes are in Excel. Hopefully at some point, Skyward. Hopefully at some point in time I can show them to you this week, and we can talk about it a little bit. Obviously not today, but I've also got to get those other quizzes made up. So, okay. Give the homework a try. Let me know if you run into problems. We will go from there.